My dear students, today in this lecture we are going to discuss about SR latch. SR latch stands for set reset latch. S stands for set, R stands for reset. Now let us look at the diagram how exactly it look like. So one input is yes, this is set input, and whereas this is reset input. What we are using in this circuit is we are using NOR gates, two NOR gates we are using, and what extra that we are doing is we are connecting output of one NOR gate as input to the other. Output of one NOR gate is connected input to the other. This sort of connection is known as feedback. This feedback is responsible for getting memory in this circuit. For this circuit we are getting memory because of the feedback, right? To understand this circuit, what we should know is we have to know exactly what exactly is truth table of NOR gate. Let us say I have a NOR gate. I have two inputs, let us say A and B, output is Y. So how it is going to work? A, B are inputs, Y output, 0, 0, output 1, 0, 1, output 0, 1, 0, output 0, 1, 1, output 0. Now from this table, can we say anything in one single statement about NOR gate? Yes, possible. What is that? Is if any one of the inputs is 1, output is 0. Okay, this is the basis for analysis of this circuit. Now first what I do is I will make set is equal to 1. The meaning of set is equal to 1 is if I make set is equal to 1, output will get set. So reset is equal to 0. I never do set reset at a time. Either I do set, if I make set equal to 1, then my Q becomes 1. If I make reset is equal to 1, this is how it is being designed. My Q becomes 0. Okay, that's how exactly it functions. Let's check it. So I don't know about what exactly the value of Q1 right now, but I know one of the inputs. But what I know from the table, if any one of the inputs is 1, output is 0. So output 0. Why? If one input is 1, that is enough to say that output is 0. I need not look at the other for sure. So when this is 0, this itself is input to the this. So what exactly that is going to happen is this is 0 and this is also 0 right now. 0, 0, output is 1, so output 1. So when S is equal to 1, Q output is equal to 1. This Q2 is nothing but Q1 bar actually. Okay. So what is being proved is when S is equal to 1, R is equal to 0, Q is equals to 1, Q2 is equal to 0, which Q2 is nothing but Q1 complement. Similarly, if I make S is equal to 0, but R is equal to 0, same continuation. Earlier it was 0, now also I am continuing with 0, but I am changing this to 0. Now what exactly happening with respect to what exactly we have output? Right now with 1 0 output, Q is equal to Q1 is 1, this Q1 is 1, Q2 which is Q1 bar is also 0 of course. So this is 0 and this is 1. Now we are applying 0 0. When this is 1, this is 1 and we are applied current value of 0. So when one of the input is 1, what is the output? 0. Is there any change? It was 0. It was 0. Now it is also 0. Now with this being 0 and this is input also 0, I didn't change anything. So 0 0, I am getting output 0. With 0 0, this is 0, this is 0. For 0 0, what is output? For 0 0, output is 1. So I am getting output 1. So I am getting output 1 for Q1, I am getting output 0 for Q2, though I have changed though I have changed S to 0, I have changed S from 1 to 0, I didn't change R, but output does not change. So from this what I can say is, when S is equal to 1, R is equal to 0, output going to set the value. When you give 0, 0, there is no change. When I give S is equal to 1, then Q becomes 1. Of course, when Q and Q bar is complement of Q, so it's 0. Here we are calling it as Q1. Okay. Let's make R is equal to 1, whereas S is equal to 0. Okay. So let us take the eraser and remove the previous values, whatever we have. Okay. Now let us start the discussion freshly. What we are doing? Just we are looking at circuit functionality when R is equal to 1, when R is 1 and S is 0. R is 1, S is 0. R is 1, S is 0. When one of the inputs to the NOR gate is 1, output is 0 from this table. So output is 0. I don't know what exactly this is right now, but I know that this is 1. One of the input is 1, output is 0. Without knowing the second input, I can say that. When this is 0, same thing is propagated over here. Of course, this is 0, this is 0. 0, 0, output is 1. Okay. This itself is Q1 bar. So I am getting Q1 is equal to 0, Q1 bar, which is nothing but Q2, as 1. 0, this is 0 and this is 1 when 0, 1 is input. Similarly, here it was 1, now it is 0, 1 0 case I have said. What I do is, now I change R, but I keep S as it is. So what is R? Earlier it was 1, now I am making it as 0. Earlier it was 0, I am continuing with 0. So now I am giving 0 0 as an input. But previously, what is the value that we have with respect to Q1 is 0, this is 0, 0 0, output is 1. Earlier it was 1, now also new value is also 1. Okay. So this is 1. When this is being applied over here, this is 1 and you have changed it to 0. Which one? R changed from 1 to 0, R changed from 1 to 0. From feedback I am getting 1, 1 0, output is 0. So it was 0, now also it is 0. So Q1 0. So this is also saying that no change. Now we need to understand here how it is no change is Q1 1, Q2 0, 0 0 applied, no change. Let's suppose Q is 0 and Q1 is 0, Q2 is 1, which is Q1 bar itself. Okay. Even if you apply once again 0 0, no change. So no change is the case where when you apply 0 0, whatever the value of current value of Q remains same. If it is at 1, it will continue with 1. If it is at 0, it will continue with 0. That is what exactly one has to understand. No change. No change means in digital, the values are 1 or 0 possible. If it was at 1, it will continue with 1. If it was at 0, now it will continue with 0. That is what exactly one has to understand with respect to no change. So next what exactly we try to do is, we apply both the inputs once. So in order to understand this without any difficulty, what I need to do is just I will remove all the outputs right now I have. I don't want to, okay, the clumsy writing. So let's remove everything just to look at what is the input being applied and how exactly it is going to function. When this S is equal to 1, R is equal to 1, we would like to analyze the circuit. To analyze this circuit NOR gate, do we require the second input? No, not required. Why? When one of the inputs is 1, at least if one of the inputs is 1, I can say output is 0. So this output is 0, this output is 0. Okay. This output Q2 is Q1 bar actually. So we are getting Q1 is equals to 0 and Q1 bar is also 0. that is the issue here. So this input of 1 1 is invalid input. When you are working with SR latch, you should never apply S is equal to 1 and S is equal to R is equal to 1. Okay, this is known as undefined. Okay, so this is about SR latch using NOR gates. Okay.